Alright, this will just be a quick video. I'm running you through your homework page. I had a request that I show some of these worked out. So I'm just going to start from number 1. You can kind of fast forward through the video, but just make sure you're listening on the ones that you really need help with, especially the stuff that we covered today in class. So number 1 was just what percentage of water is found in copper sulfate pentahydrates. This is copper 2 sulfate. It's good practice to keep naming these things. Pentahydrate. Okay, and so in order to do your percentage of water, we would figure out 5 times the molar mass of water, which is 18.02 grams, all taken over the molar mass of copper 2 sulfate pentahydrate. So all of it all added together. So we're just going to go ahead and I'm just going to show that work. So you would have had 63.546 plus, now I'm going to do my sulfur, 32.066 plus 4 oxygen, so 4 times 15.999. And all these numbers are just coming from your periodic table. Plus that 5 times water's molar mass, which, just a friendly reminder, this 18.02 is coming from 2 hydrogens at 1.008 plus 1 oxygen at 15.99. So I gave you guys permission to just round it to 18.02. All right, so now that we have our top number and our bottom number, we're going to plug all that into the calculator. So I'll go ahead and pause the video so I can get it plugged in, and then and you can have a chance to plug it in on yours. So just pause your video. So when I plugged that in, I ended up getting sorry, this is all of this, so more like that. We got 0.3608. We're going to multiply that by 100 to make it a percent to get 36.08% water. So that's your answer for number 1. Number 2 is going to be the exact same calculation, so I'm not going to run through that one. Number 3, we're looking at a different wording on this. So now this brings in the words of hydrate and anhydrous salt. So what that just means is this is the wet, this is the dry. And just like our notes today, wet minus dry equals water. And you're going to need that to figure out this formula. So the question itself was just asking for what is the percentage of water in the hydrate. And so what you're going to do is you can actually just take your 4.3 divided by 5.0 times 100 to get you 86%, and that is of the salt, so the barium chloride. And then in order to get the other one, you could have just done 100 minus that 86 to get your percent of water, which would have been 14% for the water. So that is what the actual question was asking, but today in class I mentioned I want you to come up with the formula. Okay, so now I'm just going to go into how you could do that. So you can take these percentages and just use your empirical formula steps to figure them out. So that's what I'm going to do in this example. So we have 86% barium chloride, so I'm just going to have 86 grams of barium chloride. In your notes today, this was who we labeled as AS, or anhydrous salt. Okay, but we have 86 grams of barium chloride. We're just going to divide it by its molar mass to convert it to moles. So we're going to take 1 barium, 7 0.28 plus 2 chlorines, so 2 times 35.453 to get 208.234 grams. So now I have what we need to get this moles of barium chloride. Just shrink this off to the side. Okay, so I'm going to have 86 multiplied by 1, push equals, divide by 208.234, and I get 0.412997. Okay, try not to round too much on those numbers. And then the 14%, we can just assume 100 gram sample, just like in the empirical formula notes. So 14 grams of water, and we're going to divide it by the molar mass of water, which is 18.02 grams. So when I take 14 divided by 18.02, I get 0.77. So if we notice, 1. So if you notice, our smaller number is the anhydrous salt, which is what it should be. So our next step is to divide both these by the smallest so that we can get a ratio. So this one we get 1 of our anhydrous salt. And to figure out water, we're going to divide those two numbers. So you get 1.88. Since this is lab data, those numbers don't always come out the prettiest, but this is close enough to round up to 2. And so, like I said, with lab data, that's usually what we have to work with. So the way that we would record this answer is we would have barium chloride, put the big dot, dihydrate. And that was the answer for number 3. Okay, so I'm going to kind of zoom this off to just over here. Pause the video if you need to look at that a little bit longer. I'm just going to go ahead and show number 4 without getting the percentages of water. So you would still do this percentage of water in the hydrate the same exact way that we did right here. So you can still do that, but I'm going to show you if we don't have to solve for percent, which you don't always have to. So looking at what our question is asking, we have 2.5 grams sample of hydrate, so this is wet, okay, and we have 1.5 grams of dry, or 1.7 grams, sorry. Wet minus dry equals water. So if we take those two numbers and we go ahead and subtract them, move that a little bit further up there, sorry, okay, if we subtract 2.5 minus 1.7, that should give me my water. And so you find it to be 0.8 grams of water. So from here, I'm just going to convert my grams of water to moles. So 1 mole of water is this 0.8 grams divided by the molar mass, which is 18.02. So when I divide those two, I get 0.0444, really. And then we have moles of water so far. We also need the moles of our salt, our anhydrous salt. So we're going to go ahead and take the dry. This one was the one that was labeled as dry. So I have 1.7 grams of calcium nitrate. I'm going to divide that by its molar mass. So I'm going to pause the video again so I can calculate the molar mass. You should do the same. You're going to add together 1 calcium, 2 nitrogens, and 6 oxygens. Okay, so to convert that to moles, I got 164.086 Now that I have that mass, I'm going to divide the 1.7 divided by it to get a 0.0104. So once again, the salt comes out smaller, which is what we want, because our next step involves dividing by the smallest. So we're following my empirical formula steps, right? So we're going to divide by the smallest amount of moles to where this one will come out to be the number 1. So we're comparing it to that. And then the top one comes, or your water comes out to be a very ugly number, but that's okay. We're going to put what we've got, so 4.26. So just like I had stated up here, that with lab data, you don't get the prettiest numbers, the prettiest ratios. So this one is actually close enough in the lab area, not on all the other worksheets, but on the lab area. This is close enough to round down to 4. Again, do not do that during an empirical formula worksheet. But for hydrates, since those are all based off lab data, there's lots of errors out there. This one is an okay one to round down. So we would round that down to 4. So what we would be left with is calcium nitrate tetrahydrate. So that is how you would solve numbers 3 and 4. So just to kind of keep looking at what else is covered on this page, because it's still, there's some more stuff that's different. Number 5 is one that you would figure out your percent. So our percent of water, there's only one water, so we have 1 times the molar mass of water, which is 18.02, all divided by your whole formula mass. So I'm going to have 2 times sodium, so 22.990, plus a carbon, which is 12.011, plus 3 oxygens, plus my 1 water. So I'm going to go ahead and get that typed in, and we would get times, you would get for this whole thing 0.1453. We would multiply that by 100 to have 14.53% water. Okay, now that's not the answer that they're looking for. They wanted to know how much salt remains in this 3-gram sample. And so what you need to look for is that if that's the percent of water, then we can turn around and we can say 100 minus that 14.53 will be 85.47% anhydrous salt. Okay, and this is the ratio thing that I had set up a couple days ago, where we said, okay, if I am, sorry, I'm going to be zooming in on my screen over here, so I'm just going to kind of basically, if I have 85.47 out of 100 is equal to X out of 3. So you set up a proportion. You can do cross multiplication. So you multiply these two, and you'll divide by the 100. So we'll take 3 times 85.47 divided by 100, and we would get 2.56 grams as our answer. Okay, so that's how to do number 5. 5 is kind of different from what we took time to do in class today. Number 6, if you needed to see that one again, I know that we tried doing it in class together, but if you weren't able to get me over to help, please make sure you watch this part. for number 6, we had a 5-gram sample of that copper 2 nitrate and 3.9 gram of the anhydrous salt. So what that tells you is that we had our wet minus dry. So we would have taken that 5.0 minus 3.9 to get 1.1 grams of water. So that would have started your calculations off by, we would do 1.1 grams of water. We would divide that by the 18.02 to get it into moles. So when you do that, we would get 0.0610 moles of water. And then we would be using this 3.9 to describe our anhydrous salt. So I'm just going to put anhydrous salt, okay? But please know that it is CuNO3 2, okay? It's copper 2 nitrate. So if I have 3.9 grams of that, 1 mole, I need the molar mass of this. So that means I'm adding together 1 copper, so 63.546, plus 2 nitrogens, plus 6 oxygens. So you should have a 187.554 grams. So when I divide 3.9 divided by that big molar mass, I get 0.0207. Oops, I did not mean to say grams. Moles, okay, of this copper 2 nitrate. So out of these two values, I'm going to take this one and this one. Okay, we're on step 3 of your empirical formula. This is where we divide by the smallest. So this one is the smallest. We're going to divide both values by, so I'm just going to rewrite them right here so it looks a little bit prettier. Moles of water divided by 0.0207. And we're going to have 0.0207 moles of your anhydrous salt divided by 0.0207. So we divide both of them by the smallest number, so that this one comes out to be a 1. This one will come out to be about a 3. And so then we finish off with our formula, which is just copper 2 nitrate, big dot, 3 waters, trihydrate. That should get you through the whole worksheet. Hopefully that helped.